Let's keep going. Now, with identities, the purpose of them is so in calculus, we can then go ahead and simplify things to make it a lot easier on ourselves. Okay, not necessarily just to use for now, it's really used for next year. Okay, that's the purpose of them. Some of you guys maybe struggle. Can anybody tell me why you struggle with identities? There is memorization required, yep. Yes? It's not a formula, huh? Exactly. So is it routine like you could follow example number 2? I'm going to follow this and it should be able to help me with my problem. A lot of times that's what it looks like a lot of times, right? Law of science, I gave you an example. Oh, it looks like this guy. I'm going to go back and try with him, correct? But with identities, you have to try. If you just say, I don't know, you're done, which is with everything. But if you get stuck and you stop, you're done again. You have to persevere. You have to push through. Does that make sense? You cannot stop on yourself. You have to say, all right, this didn't work. What else could I have done? What could I have done at the beginning? Are they going to be a little bit a pain in the butt? Sure they are. But hopefully I give you enough information that we can do it without it, okay? But that's up to you to practice these, okay? There are certain things that I am going to ask you to memorize, and we'll start here. So we already know what sine is, right? By the way, this is 5-1. We already know what cosine is. We already know what tangent is. But tangent has another name besides 1 over cotangent, which is true. Sine has a different name. That is 1 over cosecant. Now, I really don't use this name, to be honest. I don't use these guys a lot, but they are there if you need to. But this one does have another name. Anybody know? It is sine over cosine. And that should make sense because isn't sine the opposite over hypotenuse? Correct? What's adjacent? Adjacent over hypotenuse. When I have a fraction over a fraction and I go ahead and times by the reciprocal and I get O over A, which is tangent, which notice is sine over cosine. Does that make sense? Okay. We should all know that cosecant of x equals 1 over sine of x. That should be nothing new, correct? We also know that secant of x is 1 over cosine of x. We also know that cotangent of x is equal to who? 1 over tangent. Good. What else do we know, though? What? Cosine over sine? Okay, those are all items I'm asking you to memorize. Which we already know most of those anyway, don't we? Correct? Yes, sir. I guess so. I mean, yeah. Sure. Not, yes. I'm not usually, yeah. Way to go, Chuck. Okay. Yes. Oh, no, that's Eichelberger saying, hip, hip, hooray. Now, there is an important one. I do it slightly different, just thinking about it. If we did this, where this is an angle, we have this specific point up here. We know that usually our y value is who? On the unit circle. Sine. What do we know about the x value here? It's cosine. And because this is a right triangle, what do we know? Sine squared plus cosine squared, because of Pythagorean theorem, equals 1. How many of you guys remember that identity now that you've seen it? 4. Awesome. 5. Okay. And Paige, we studied this a little bit, I think. Just tiny. Yeah. That's right, Pagers. I'm gonna reach to the stars with my fingers and go. Okay. All right. Well, some other Pythagorean identities come from this. I'm going to go ahead and divide everything here by sine. What's sine squared divided by sine squared? Sine squared divided by sine squared. Sorry, I apologize. 1. Sine squared. 1. What's cosine squared divided by sine squared? Cotangent squared. And what's 1 divided by sine squared? 1 divided by sine squared is cosecant squared. Anybody have a question on how I found those? Well, that one I just divided by everything by sine squared, so what do you think I'm going to do for the other one? Divide them by cosine squared. What's sine squared divided by cosine squared? Tangent squared. How many did Mr. Benight go over this? Just made you memorize it. Didn't even talk to you about it. Just said, here it is. Know it. Well, that sucks. What is cosine squared divided by cosine squared? 1. Cosine divided by cosine is 1. What's 1 divided by cosine squared? Secant. Ladies and gentlemen, these are called your Pythagorean identities. If you know this fella is your best friend. He is. Who's your best friend? Your best friend's yourself? That's a little interesting. Oh, that's why she's gone. I remember now. I'm so impressed that you guys still have those notes.
Oh, never throw them away.
Why? Is that what she said?
So I'm gonna come back.
Awesome. No, that's exciting. We get to send. Why did she go over that stuff? Centroids? No. It's a polar. Oh. Are you talking about? Oh, that's different. I was thinking something else. Okay. This lovely thing, guys. If you will look, if you ever want to, it's page 374. Those have some identities in your book. Hi. Thank you. She did it via interesting triangle, yes. Snuckers and duckers. Memorize those. Here we go. Here's our first example 1. Example. Now, some of you guys might remember verifying identities and simplifying identities. What's the difference? Well, this is called simplifying. We're trying to make this a smaller usable unit. Okay? Verify is what we're going to do next time. And there's equal signs, and they have stuff on both sides. You have to prove that side to look like the other. Does that make sense? You guys remember that? Will I give you a note card? Maybe. I'll show you the stuff that this is my rule. If I don't know it, you shouldn't have to know it. If I can remember it, that's on you. Because there's some reason why I had to memorize it myself. Make sense? Okay. What do those guys share? Does everybody see that? So what are we going to do? We can't divide. We factor out. Oh. That's all right. I want to play chess some more. Daniel hasn't only played me. Did you guys have Daniel in your class? Daniel. And did he say it was good or bad? There's days I do all right. Huh? Well, you can't always win it because if your first choice is a bomb. How do you know in their programming? Because they all of a sudden change after that? So they place the bombs after your first click? Really? Because I've screwed up on the very first time. Where is Minesweeper? I haven't seen that in many moons. Baggers? Well, I'm just curious if it was in my programming like it used to be, okay? Huh? Maybe. Well, it's 30 years since the internet's been invented. Hey, shut your mouth. I just wanted to see. I don't like to cheat. I'm not a cheater. You guys are killing me. What the hell is this one? Shit! That just messed me up. How do you... I can't remember how you make it go quicker. If you click this one, you hit that side? No. Oh, that's what it was. Huh? Because this used to be highly good entertainment back in the day. Nope, you have to click both the left and the right button at the same time. Oh, that was going to give me some room. Oh, one more, dang it. I know, shush. Oh, a fiver! Hold on, hold on! How is that cheating? Sorry, guys, we have to... Oh, I'm recording this. So, we just got finished some minesweeping. Okay, just to let you know, I am a kick A minesweeper. I got to show everybody that I won. I won. Just want to make sure everybody knew. Okay, so question, back to Mathematicas. What do we know about cosine squared minus 1? That's not exactly one of our identities, but it is. Negative sine squared, correct? How did you find that? Well, let's take a gander. Up here, you know that sine squared plus cosine squared equaled 1, correct? So if I go ahead and subtract that 1, then I have cosine squared minus 1. I want to get rid of him. Equals negative sine squared. So that's how you kind of found that, right, Templeton? Is everybody with me there? Do you see how I manipulated one of my identities to make it look like something else that I could play with? Okay. So therefore, this is sine of x times negative sine squared of x, which is negative sine cubed. Okay? Now, what if you didn't see that cosine squared minus 1 is negative sine squared? What do we know 1 is? What's another name for 1? Sine squared plus cosine squared. So if I put a parenthesis here and go sine squared plus cosine squared, notice that negative sign's right there. If I distribute it through, I have cosine squared minus sine squared minus cosine squared. The cosine squareds would cancel out, and I'm left with negative sine squared, wouldn't I? By the way, I need to bring up a little details here. I'm trying to get rid of my Girl Scout cookies. If anybody's interested in bringing to buy some Girl Scout cookies, I'd appreciate it. But it's up to you guys. $4 a box. Not unless you're buying s'mores, it's $5, and I have one box of those. Okay. With that also being the case, Pi Day is next time. And since we're in math class, we have to semi-celebrate Pi Day. Well, it's just Pi Day. I don't really care about it, but no, I don't really have to eat pie. I choose anything circular. Pie's all about circles. If you want to bring cake to share, you want to bring cookies. Girl Scout cookies are great. They're $4. Anyway, I know it's after lunch, but if you would like to bring anything, that is an extra credit opportunity. It's equivalent to going to a dance. If you bring one cookie, it better be big enough to share. I would prefer something close to share for the class. I am not, as long as you're not going to feed us pins and needles. Sure. That's a little awkward, but yeah. Okay. So, if you so choose to do so, that's great. If you so choose not to, hence why it's called what? Extra credit. Do you really?
I don't know, man. It saved me more than more.
Has it?
Yeah, it saved me something more than more.
This term? I know. Did it? Where did you go do?
Like, I don't know.
You done messed up.
What did I do that? Yeah. So the first and second term I got perfect DNA with 9 topics.
Okay, let's do the next one. The goal of this is to factor. But I'm unable to factor. The reason why I am unable to factor is because we're in different terms. Notice I have one cosecant and a cotangent. It's kind of like y squared minus x minus 3. Can I factor y squared minus x minus 3? No, senor, I can't. Okay, but I do have a name for him. Hold on. Yes, I'm assuming their gender. I know in this day and age that's a hard thing to do. Do you know if I said he, that's actually a plural of both. That's why I said, hey guys, that's a plural of both genders.
Technically, you should be able to watch people and be like, hey gal, how's it going?
And when I see just females, because it's not the same. Talk about the English language. Well, we're not in damn Spain.
Oh man.
Okay, somebody tell me another name for cosecant squared. What? I'm going to switch it to cotangent squared plus 1. Because they're equivalent. They're identities. That's our Pythagorean identity. If you would like to look on your paper, it's probably staring right at your face. Hi, Riley Sagers. How are you, buddy? I'm sorry you didn't get 100% for the whole quarter. Were you going for that goal? You did good, though. Impressed overall. Yeah. Hey, now I could say this is cotangent squared of x minus cotangent of x minus 2, correct? I don't know about you guys. What would you do if it looked like this? U squared minus u minus 2. I think I'd factor like a freaking tractor. Okay? I'm able to factor u squared minus u minus 2. Whose are u? U is cotangent, isn't it? So therefore, it's cotangent of x minus 2 and cotangent of x minus 1. You okay? You're saying you're not good at it. You can work to be good at it. Well, all I'm saying is I would suggest not to retake this one because this is not going to be the hardest one for the quarter. I think the last one's going to be beast one. Polar. No, not polarity. Huh? Because I can, hey, that's a good question. So notice, I noticed that this are just kind of like u's. That's something squared minus something minus 2. Something squared minus u minus 2. You see how this right here can relate to him? If I use, you remember we did u substitution before this year. So therefore I said, oh, what's u? Cotangent, and then I basically just factored it. Just got to look at it as something different, right? And that's hard. It's hard to do. Okay, let's think about this. Let's go to another one just for you. No, I love it. How would I do if this was equal to this? That is equal to cosine squared, by the way, but it's okay. What is this also equivalent to? I could factor this. I could say that sine, oops, I need an x there. Sine of x minus 1, and sine of x plus 1, because they are a difference of squares. Does that make sense? Difference of squares going to conjugate pairs, right? Grace. That's right. We'll rock you on this problem, Isaac. You could, brother. Well, like I said, I just wanted to show her that you could factor. Okay? Can I borrow your book for a minute? I forgot what's my next example. I can just look. We're not in chapter 7, I will tell you that. We're in chapter 5. Eichelberger, guess how quiet it's going to be? I'm excited. Hey, I have a right. This is my room, damn it. Well, it is your math classroom, but you don't get to have to stay here all day. Okay. What? This is my 4th classroom here at Westlake High School in 10 years. Should we count them? I was in, hold on, we'll do it over here on the side. I was in room C 136 for 1 year. 1 year. I was in C 133. I gotta think. I believe 4. Nope, 5. 5 years. I was in C 141 for 3 years. And then I was in C 131 for, this is my year. I'll be in the D hallway on the very end of, like, if this is the D hallway and this is the end of it, I'll be upstairs in that one. I have enjoyed that was my one that's right next door. I have enjoyed that one. C133. It's the same as this, except I don't get the annoying bathroom thing, you know what I mean? And I did enjoy C141, but I had student council in there, which I enjoyed doing student council, but my room was always a mess. Don't judge. But there's always stuff around because they had projects, you know what I mean? All right, anybody have a question on what we're doing on this one? What is this one? Anybody see an idea? Raise a hand. Okay, what do you got? I don't want sine over cosine. It is 1 over cotangent, which is sine over cosine, which I want cosine over sine. Is that what you were going to say? Miss Brown? Yes? No, you weren't. You said timesing. You are right. You are right. I'm sorry. Hey, guess what? Hey, whoa, Gimpy. Shooter. I don't know about you guys. When you see a number, because that's what cosine is, times by a fraction, Eichelberger. When you take a number and times it by the fraction, that's what I would do first. Is I'd times those numbers together. Would I not? What did you just say? Thank you. I about slapped you. No.
No.
That is illegal. Hello out there, those people. They must be having a break. Who gives students a break? Lots of people, from what I've been told. Yeah, why? It's not really weird. So, is his wife going with? Hey, peoples. So I have a number plus a fraction. A number plus a fraction. What do I usually do when I see a number plus a fraction? I get a common denominator, don't I? I think you said that, Kels. So I'm going to times by sine top and bottom. Nope. Because I times by 1. I'm going to kick you in the face. Huh? Now, because I have a common denominator, I can add the top. All right, whoever's whistling needs to be done. If it ain't me, it ain't for you. Cosecant. There it is. We made a cosecant. Yes, we did. We think about things and you're guided by me. So, but the thing is look at it and say, what would I do if these were numbers? Because that's what they are. They're numbers. And kind of rationalize yourself through that process. Okay? Onward to the next problem. What did you hit? A mine? You were hitting a mine? I didn't get one wrong because I know how to play that game. No, that's not what I want. You never played Minesweeper? What kind of childhood did you have that you never played Minesweeper? You're like one with technology? Bubble Bobble? No. Okay, I'm going to pick on Connor. Connor, what do we see there? What's sine over 1 plus cosine? Ladies. That's a fraction, right? What's the other side, Connor? Another fraction. When you see two fractions, Connor, what do you want to get? Common denominator, right? So what am I going to times the left side by? Nope, it is not. I'm going to times this side by sine. Does that make sense, Connor? Because that's what the other side is. Once I do to the bottom, I got to do to the top, correct? What about this side, Connor? Good job, Connor. Okay. So I multiply the top, so I get sine squared. Notice I will have a common denominator. I'll put that down in a moment. Plus, I'm going to distribute this cosine in. So I would get cosine theta plus cosine squared theta all over sine theta 1 plus cosine theta. Riley, is anything going beep, 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 beep in your head? Damn it. Hey. So, you're not supposed to tell me who you learned it from, but who'd you learn it from? The kick. I saw you guys kicking in New York, in the studio. It just said that she wasn't allowed to say, but I knew it was. It was fun? Good. Good. Yeah, go ahead. You got a nice black marker. I don't know. Has your hair been that long since I've known you, Tana? Are you? Why? She's a little nervous for you. That red one might not work very well. Pi Day is on Thursday. Pi Day on Thursday. It is actually pretty big for us because they get extra credit that day. No, not necessarily pi. Circular items. You're not even going to be here. Hey. No. That's the monkey. Okay, here's what I have. Somebody should be ding-ding-dinging because of him. It is 1, thank you. You remember trig identities? Which, that's the part that you don't get. And isn't that what we had on our last problem? So tomorrow's lesson, it is on Thursday. Tomorrow's lesson is on Thursday. It'll basically say this red equals, yes it is, equals this purple. That's most likely what next time's lesson will is say, how does this guy equal this guy? Because they both equal cosecant, so don't they equal each other? And that's what you'll be doing tomorrow or next lesson. Not necessarily. There's an infinite amount of things that equal to it. What? I don't know. I told you it didn't work. I have here, borrow. Sorry. No, there is no E in pi day. It's just PI. Did you put PIE? Damn you. Hi. Hi? Yes. That's the word pi in Greek. The number. Well, not the number, but the abbreviation. Pi. Pi. No. It's like alpha. You are silly. Okay, next. Here we go, finish it up. What do you think we should do? Oh, it's a song that everybody knows. Teresa! Okay, everybody stop. Now stop, I'm done. I'm done! I can't handle anymore. Okay, so this guy, he's almost kind of simplified already. Okay, but anybody know what we should do? No. Yes. I could, but that would go in a big circle I don't want to go. Chuck? No. It's just sine. I can't do 1 plus sine squared and make it something else. No. What? All I know is 3.14, guys. Did you guys ever see, what's the guy? Pi? What's this guy's name? The show Pi? What the movie is that? Pi? Life of Pi! Because they nicknamed him Pi. Because he memorized pi. Yes, for a certain amount of digits. Pi. Yes. All right, so here's your hint. There's a guy that's in jail. He drinks out of an item, and he just got done eating. What's another name for a guy in jail? Okay, prisoner is correct, but that's not it. Instead of a pro, it's a con. Okay, you drink out of this item, and you might drink it like this. What kind of? That's true, all those items. But what kind of item is it you're drinking from? Like a jug. Okay, you stop. Stop, just stop, because you're not even getting close. So we have a prisoner who's a con, drinking out of an item, which is a jug. He's drinking out of a jug. And if you've already ate, okay. So, whenever you see something that's just like this, a number plus a trig function. Okay, if it's not squared or something, you usually get it times by its conjugate. Con, jug, 8. Hence all those things I just said. A con that just drinks out of an item that just got done eating. Pretty good, isn't it? Thanks, Kels. Thanks, Kels. Huh? Secondary 3, honors. The one that you were with me last year. And because you were on a trip, but it's okay to have an A-, Tana. I understand. I understand. Tana, look at me. We're okay. Tana. I know. Go do your thing. You get your thing. You need to get control of yourself. Okay, so when I multiply conjugates, what happens is once again, conjugates go into a difference of squares, don't they? I wonder what this looks like. Looks like cosine squared, because 1 minus sine squared is cosine squared. That's an identity. Hello, where have you been? Bad day to miss, Chicka. Bad day. You had to, or what if your grade now suffers in here? I'm excited because this is a tough one. Okay, so question really quick. Somebody do not tell me negative 1/3 or I'll kick you in the freaking chin. Tell me negative 1/3, I will seriously come kick you in the chin. What's another way to rewrite this? Yes. Well, I just want something other than that. That's correct. I'm not saying that's not right. I would like somebody to tell me what this is. Huh? So I think Kelsey said it, or did you say it, Gerby? Say what you said, Gerby. 1/3 minus 2/3. Now, why do I care about that? It looks very similar to this. Right? Does everybody see that? So that's 1 over cosine squared. You jerk. Minus sine over cosine squared. I'm going to make cosine squared look slightly different. Isn't cosine squared just cosine? And whenever I have a lower degree on top than the bottom or bottom and top, see how I have a cosine squared and a sine. I don't have a sine squared and cosine squared, do I? So therefore, I'm going to split them. And the reason why I'm going to split them is, if you'll notice here, what is this pair? Tangent. What's this pair? Hold on. I need to make sure we have a 1 here for a minute. What's this pair? Okay. So therefore, I know that this is secant squared minus, we already know what this is. What's this? Tangent. We don't call it tan. He's not on the freaking beach. Shut your pie hole back there, Templeton. 1 over cosine is secant. This is where the book stops. But I had other students that wanted to pull out a secant. And that's where I get frustrated on this, is because sometimes it's hard to know when to stop. So today, guess who's your best friend? Bob. Bob is your friend. Okay? T-Bob. The back of the book, got it. T-Bob. Okay. That is truly our last example. If you would like to turn to page 379, I will assist in any of the even problems that you would like me to go over. Huh? I will, but I'm not quite done with my lesson. Is anybody like to go over an even number? Rafe, do you mind looking to say, hey, I wouldn't mind just seeing look at this one. Have you ever ripped your pants in school before? I did it 3 minutes before parent-teacher conference. I seriously, I got out of a car and my legs split a little bit too much because I slipped and they ripped because we were just coming back from dinner. And I went over to the principal. I'm like, I'm going home. Yeah. Are we good? Are you guys, Rafe, you got one? $48. What does it say, Rafe? Cosine, hold on, cosine squared of x. I'm going to go x. That's a good one. Is that what it looks like right there, Rafe? Okay. What do those guys share? They both share a cosine squared, right? Nope, just a cosine squared. What's left? 1 plus tangent squared. That should be ringing bells in your head. Secant squared. He's calling the other elves. Cosine squared times secant squared is 1. Because that's cosine squared times by 1 over cosine squared. Right? Anybody else have one? 7. Oh, I don't think we're going that far. Sure we are. 76. What does it say? 1/2. Bracket or parenthesis. Got it. 1 plus sine of theta. This right here is over cosine? All of that? Close the parenthesis? Not yet. Cosine of theta. This is very similar to what we did in our homework, on our notes. Because what would I do? I'd get a common denominator. So therefore, I'd have 1 plus sine squared. And this would be cosine squared. Now we're at the same common denominator. So if I FOIL this out, I get 1 plus 2 sine theta plus sine squared of theta plus cosine squared of theta all over cosine. Notice this is a half out here still. Of 1 plus sine theta. Okay. What is the top? What can we see? We should be saying ding, 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 ding. I almost erased that. Ding, ding, ding here. What is that? 1, isn't it? What's 1 plus 1? 2 plus 2 sine of theta over cosine theta. 1 plus sine theta with a lovely a half out here. Can anybody see something on top that they have in common? They have a 2. So if I pull out that 2, I'm left with 1 plus. That's kind of messed up there. Watch. And then 2 times a half. Which is? Which one is it? There it is. No, they can't be anything. You're trying to go further as far as you can. Many different things. Yeah. Okay, back to the homework. Yes, we are. Back to the homework. Hody, hody, hada, right there. You guys have 25 minutes if you'd like to use your time wisely. My book's sitting right up there. It's on page 379. If you'd like to take a picture, because you didn't bring yours today, you might want to take a picture of the back of the book as well. If you would like to check 5-2, the homework's in there. For next, if it's highlighted. And then there's another one in my printer that you might want to go pick out. That's on Monday, but you're supposedly supposed to be back here on Monday. Hi, Ethan. You okay, buddy? You want to leg wrestle? So tell me more. Who else is going? Why? There's homework right there. Homework up there. No, up in the book for your next time. So tell me, how many times are you singing? A lot? Is it a competition? Or is it just you're going to go find some places and sing? What kind of church? And she's like, doesn't matter. We're going to sing a fun song and they're going to clap along. So it's not an LDS church. Tana, will you get me water? Yeah, Tana. Just in the drinking fountain's fine. Sure. Nice job. Huh? Chuck, are you going to be here Monday? Ooh. Chuck. Chuck. You running? No. You better change some of your ideas, buddy, because you think way too damn much. Okay, so he's going to kill us. Nope, I think you should not run for president. Hold on.
I don't think you're going to get many